Hey guys, today we get into some of the most exciting things I think about robotics. I am going to teach you about a tool in Python that will allow your robot to make decisions. It's called the if-else statement. It's a really powerful tool. We'll use it on pretty much every assignment from here on out. And it's really neat because using if-else, we can basically get our robot to make choices, to make decisions. We can make it think, basically. So let's go ahead and get into this. We're going to start right here on this assignment, and that's RB number 6, the safe distance assignment. We're just going to do this one together here in this video, okay? So let's start from the top. Who must do this assignment? All in-class and virtual students must do this assignment. Right now, please do the following. So let's go ahead and do these things as it shows us. And so what you can do is you can watch me do it here in the video. You can pause the video and then go ahead and do it in your own simulator tab. All right, so number 1 says, click here to open the robot simulator. So I've got the robot simulator open right over here. And then number 2 says, draw an obstacle along the left-hand edge of the simulator with these numbers. 50, 400, 400, 400. Okay, so I'll pop into the simulator here. I'll click my obstacle button, and we've gone over this in class, but between these two brackets, I'm going to type in the code. Okay, so I'll put another 2 brackets in for the individual shape, and it said 50, comma, 400, comma, 400, comma, 400. I'm just going to browse back and make sure that looks correct. All right. And that's correct. So I will click apply. And there we go. We have our robot with a big pink square. That is our obstacle. Number 3 says adjust the robot's starting angle to 180 degrees so it is looking at the object, and adjust the robot's starting X value to 600. So basically we're going to scoot this robot around a little bit. So this guy goes to 600, the X value does, and the angle goes to 180. So we pointed the robot toward the obstacle and scooted it very close so that it's looking at it. All right, so let's go ahead and read these instructions. To pass this assignment, you must write a program in the robot simulator that gets your robot to A. Robot uses ultrasonic sensor to measure the distance to the obstacle. B. Robot stores the distance to a variable. C. Robot uses an if-else statement to do one of 2 things. If the robot is less than 12 inches away, it plays a 1000 Hertz tone for 12 seconds and speaks the message, "This object is too close." If the robot is more than 12 inches away, it plays a 500 Hertz tone for 2 seconds and speaks the message, "This object is at a safe distance." D. Your program must use if-else, the ultrasonic sensor, sound.speak, and sound.play tone. Please see the appropriate Canvas page for these things if you need more information on them. Okay, so this is nice. It kind of gives us some stuff that we could probably just even copy and paste if we really wanted to. All right, so let's pop into here and let's go ahead and start thinking about what we need to do in our program. I know that this isn't going to move around, so I don't need to turn on my motors. I do, however, need to turn on my ultrasonic sensor. Now, we've covered this in class, but to do that, we just go from EV3 dev2 dot sensor, and I'm going to import input 1. Basically what that does is it turns on the plug that the ultrasonic sensor is plugged into. So now I need to go from EV3 dev, I can't spell, sorry about that, 2.sensor.lego. We're going to import the ultrasonic sensor. And I would pause if I were you, this video, and pay very close attention to how I wrote ultrasonic sensor. The U is capitalized, and the first S in sensor is capitalized, and there's no space between it. That's because this is a command. This command will make a measurement So I would pause now, look at that, and maybe copy what I have, and then come back to the video. Okay, so I have the ultrasonic sensor. Its plug is turned on, and now its command is turned on. And what I'm going to do here, let's think about what else my robot needs to do. It needs to make some noise. So it's going to play a tone, and it's also going to speak. So just like we did in our last assignment, we're going to go from EV3 dev2 .sound, and we're going to import sound with a capital S. All right, so again, pay real close attention. That sound has a capital S. So anytime I use that sound command, it's going to have a capital S. Okay. What I'll do now is I'll just go down. Now, remember, I don't need this blank line. I just like to have that blank line to help me keep organized. So, and because this is my kind of my variables section. So let's set up some variables here, all right? So we know that we're going to, number one, need to measure the distance to this object. So I'll create a variable for remembering that distance. So let's call it distance. You can call it whatever you want. I will use distance. And that distance variable is going to be equal to the measurement. And so remember, this is how we make a measurement. We go ultrasonic sensor, there's our command, and then we always put a parentheses after a command because we basically have to tell the robot where that stuff is plugged into. So the ultrasonic sensor in the simulator is plugged into input 1, and then we'll say dot distance underscore inches. We're going to make a measurement in inches. Cool, so we just made a measurement. That's what the stuff I'm highlighting did. It took a measurement, and the measurement is going to be some kind of number, like 22 or 3, or however far away the robot is from the object. The variable distance is then going to become equal to whatever that number is. So the variable distance is really there to remember that measurement. So we're basically going to use that number later on, okay? Let's also do this. I'm going to show you a little bit of a shortcut. I'm going to make another variable called say. And I'm going to make this variable equal to the sound. And so again, I issued a command, so I put parentheses. Now, my robot doesn't have a port that the speaker is plugged into. So because it doesn't have a port that it plugs into, we just leave it blank. So I'll say sound.speak. So anytime I want my robot to speak a message or to say words or something like that, instead of writing sound.speak, I will write say. It's just an easier way to have it do this command. Also, I know that my robot has to make a tone, and that's basically a musical note. We'll look at that a little bit more. It'll just make a beep kind of a sound. So I'll call it beep, all right? I'll just call a new variable here called beep. I'll set it up like that, and that's going to be equal to the sound, again, pay attention to the capital letter, dot, and I believe it is, let me pop back into Canvas to look, make sure I got that right, play underscore tone, okay? So that is what that should look like. All right, so we've just kind of set up some variables here. All right, now before I continue on, we're going to talk about our new tool here, and that's called the if-else statement. I'm just going to readjust some stuff here. If-else basically gives our robot two choices or two things to choose from. We're going to tell our robot, if this thing is true, I want you to do thing A. Or else, if that's not true, go ahead and do thing B. Let me show you what that looks like. Now, do not copy what I'm going to write right now. I'm just going to show you how if-else works, just so you can kind of see. All right. I could say, all right, if And then what we put after if is called a test. I'm going to test to see if something is true. For example, I could test to see if 3 is greater than 5. All right? We all know that's not true. We know that 3 is smaller than 5. But right now, this test is just checking to see, is the number 3 greater than the number 5? All right, so I start with the word if, and then I give it a test. And you can see I'm comparing two different things in my test. So what we're going to do is after the test, we put a colon, and that's the 2 dots. That's right next to the letter L on your keyboard. You have to hold shift to get it. And after I do that, I hit enter. And you might notice something strange happened. My cursor, the blinking cursor where I write, is no longer on the very left-hand side of the screen. That is because we are going to type in the commands that I want my robot to do if 3 is greater than 5. Okay, so let's just try to do something here. Okay. Let's say this. So if 3 is greater than 5, let's get our robot to say, okay, and I'm using my save variable, which is really my speak command or my sound.speak command. I'll put parentheses here, and I want it to say a message, and remember we have to put message in quotation marks like that. I'll get it to say, that is strange. And it would be strange if 3 is greater than 5. Okay. And I hit enter again, and you can still see that my cursor is indented. And in Python, that indentation is very important. We only want to indent things if we need to show that a command belongs to another statement. Right now, this highlighted say command belongs to the if statement. Okay? But I don't want anything else to belong to the if statement. So I'm going to hit backspace on my key, so I go keyboard, so I go all the way to the left-hand side again. And now I'm going to type in the word else. Else does not need a test. If needed a test, we were going to test to see if 3 is greater than 5. Else is going to use this same test, but here's the difference. If this test is true, my robot is going to do this command, right? It's going to say out loud, that is strange. Else happens when my test is not true. So let's say, get it to say this. Now, and you can see I put a colon after else, just like I did after if. I hit enter, and then it indented again because we're going to type commands that belong to else. So we could do this. We could say, all right, we'll get it to say, that is what I expected. So let's think about what the robot's going to do. It's going to start right here, and it's going to check to see if 3 is bigger than 5. Ask yourself, is that true? Is 3 bigger than 5? No, that's not true. So we got to think where the robot's going to go. If this test was true, the robot would say, that is strange. If this test is not true, it would say, that is what I expected. Let's think about that. 3 is bigger than 5. So it's going to go down here into the false case or the else case and say, that is what I expected. So let's run the robot and see what happens here.
That is what I expected.
There we go. That is what I expected. Our robot went to else because 3 is not bigger than 5. Now let's kind of reverse it. Let's try a different set of numbers. Let's see if 10 is bigger than 5. All right. Ask yourself this, true or false? 10 is bigger than 5. I hope you said true, and I hope you could see what the robot's going to do now. It's going to go down here and say, well, that is strange. But because 10 is bigger than 5. So let's try that out.
That is strange.
There we go. So how can we use this for this assignment? Well, this is where I want you to start following along, okay? I'm going to go in and I'm just going to delete my says right here. I'll delete that one, and I'll delete that one, and you shouldn't have it right now. I'm going to start out with an if and an else, just like this. So if you want to take a second to pause this video and copy what I have so that you have this if and this else just like I do, that'd be good. All right, so let's start and talk about the if statement. We know for this assignment that our robot, if it's too close to something, I'm going to go back and look at my directions, it should play a 1000 hertz tone for 2 seconds and speak the message, this object is too close. Okay? So it has to do two things if it's too close to something. So let's think about how do I say it's too close to something? And do my instructions say yes? I have a number that I'm looking for, 12 inches. 12 inches is my magic number here. Okay. So I'm going to check to see if my distance, and let's look back at our variables and see what variable is storing the distance. So yeah, there it is. It's sorry about that. It is the distance variable is storing the distance. So I'm going to check to see if distance, and I'm going to say is less than 12. So if my robot is really close to something, is the distance going to be less than 12? Yes, it will be. If my robot is far away from something, will my distance be less than 12? No, it won't be. So let's think, what do I want to have happen if the distance is less than 12? That's going to be right down here, okay? Well, according to our instructions, it should play a 1000 hertz tone and then speak the message, that object is too close. So to get it to speak, we go say, and then we'll get it to say this message. The object is too close. And it's also going to need to play that tone, which is our, up here, we called that beep, right? So I'm going to hit enter. I want this to be indented with if2. So it should be at the same level of indentation as the say command, because I also want this to happen if the distance is less than 12. So we're going to go beep. All right, and then we'll put a parenthesis. Now, this takes a couple numbers. So the first number is going to be the hertz or the pitch. 1000 hertz is a pretty high pitch tone. So I'll type in 1000 for the pitch of 1000 hertz, and then it should last for 2 seconds. That's what the second number is. So after the tone, the hertz or the pitch, I put a comma, and then the second number is how long I want that to last. So I'll go comma 2. All right, and I have this empty line here. I could keep it empty or I could delete it. I'll go ahead and delete it. Now, else is what happens if the test is not true. So if the distance is not less than 12, well, that means the robot is far away from something, right? So we know when the robot's far away, and I'll hit enter, that the robot should do two things. It should say the object is at a safe distance, and it should play a 500 hertz tone. Okay, so we're going to get it to go like this. It will say the message first. All right, the object is at a safe distance. That's the message it will play, and I'll hit enter. And then I want it to beep, I want it to beep at 500 hertz, which is a lower tone this time. So I'll go 500, comma, 2. And I've got these empty lines down here. I could keep them empty or I could get rid of them. I might as well get rid of them. All right. Now, let's look and see what this program does when I run it. All right. So my robot right now is really close to this obstacle. So what would you expect it to do? Would you expect it to do the if case? Or would you expect it to do the else case? Well, since it's so close, I'm expecting that the distance is less than 12. I'm expecting that it does, says the object is too close and makes that 1,000 hertz beep. Let's see if I'm right.
The object is too close.
There you go. Now we can test out to see if our if-else statement works. The way that you test that is you scoot your robot very far away. So to scoot my robot over here, I have to change its X value. So let's go ahead and change its X value to, I don't know, like 2,000. Hit move, and we'll test it out from here. We'll see if it still says it's too close.
The object is too close.
Now, it's telling us it's too close. That's a weird quirk of the simulator. Sometimes you have to hit it a couple times because it doesn't know that it moved. So let's try it again. Let's just hit run again just to see if it's the simulator acting weird or if my program's wrong.
The object is at a safe distance.
There you go. So now, yeah, and I'm going to run that again, just make sure.
The object is at a safe distance.
Okay, now it recognizes that our robot moved. So it went and said the object is at a safe distance because, look, it is far away. So when it checks to see if the distance is less than 12, that's false. The distance is not less than 12. So it goes and does this stuff here in else. And that is how we do this assignment. We will use if-else for a lot of other things. I hope you enjoyed it. I really do. It's super exciting. Guys, we're getting machines to think. How cool is that? I hope you have a great day, and we'll see you later.